A challenging part of chemistry is naming, also known as nomenclature. Now, the reason for that is because you can classify compounds in a couple of different ways. Your two major ways is to classify them as molecular / covalent or ionic compounds. Now, when a compound is molecular or covalent, some of the hallmarks of it are that it has no charge, no overall charge, and everything that is used to make it is nothing but non-metals. Now, when you have when you are talking about molecular compounds, there are a couple of things that you're going to do. One, you're going to use prefixes. Use prefixes. For example, mono, di, tri, etc. In addition to that, you're going to use suffixes or use one specific suffix. And that suffix is IDE. Now, to see this in action, if you had a compound like N2O, the way that you're going to apply these rules and apply these prefixes and suffixes is this element that's furthest to the left in your molecule is also furthest to the left on the periodic table. You've got two of them. So you're going to use dinitrogen. The suffix is not applied to the first element, but it is applied to the second element. Now, when you have a second element and there's only one of them, you are going to use the prefix of mon or mono. In this case, it's mon just because the first letter of your element there, oxygen, starts with O. So this is dinitrogen monoxide. You probably have some examples where you've used these rules and you haven't even realized that you've used them. For example, CO. What is that? Well, this is kind of an exception to the rule, or one exception to the rule. You probably know this as carbon monoxide. And that is the correct name for this compound. Notice how we did not use a prefix for the first element in our formula. That is correct. You do not always do that if it is single, if there is only one of those atoms. So one oxygen, we do not call this monocarbon monoxide. Instead, we just imply that there's only one by saying carbon monoxide. Now, another example molecule would be something like phosphorus pentachloride. Okay, phosphorus pentachloride. Well, our first compound, since we didn't use a prefix, or phosphorus pentachloride, pentachloride. We're going from the name to the formula. What is the element for phosphorus? Well, it's P. There is only one of them, and we know that because we do not see di, tri, or anything like that. And we also don't see monoxide, or we don't see monophosphorus because you do not use mono when we're talking about our first substance in our compound. Next is penta. Well, penta is the prefix for 5. So pentachloride, phosphorus pentachloride, PCl5. We use the suffix IDE, we use the prefix penta, and we are good to go. So those are your rules for molecular or covalent compounds. Now, ionic compounds can get kind of complicated, but we're going to keep a narrow focus for this. We're going to be specifically talking about atomic ions. One that you're probably familiar with is NaCl. This is also known as sodium chloride. Did we use prefixes? We did not. We didn't say monosodium monochloride, but what we did do was we used that suffix, IDE. Now this compound is consisting of, well, sodium and chloride. This is an ionic compound. Sodium is on the far left-hand side of the periodic table. This is a metal. It is going to form a +1 ion. Chlorine is on the far right-hand side of the periodic table. It is a non-metal, which I'm just going to note as NM. This has a negative charge. This compound as a whole has no charge whatsoever because the positive and the negative charges cancel one another out. You've probably also seen some other examples of that in your life. MgCl2, magnesium chloride. But this is where we're going to stop for our discussion of monatomic ions. We will get into polyatomic ions in the next instance. So I hope this is helpful. Have a